Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Find score of an array after marking all elements. Leetcode 2593. In this problem, we are given an array nums consisting of positive integers. Starting with score equal to 0, we have to apply following algorithm. Choose the smallest number of the array that is not yet marked. If there is a tie, choose the one with the smallest index. Add the value of the chosen integer to the score. Mark the chosen element and two adjacent elements if they exist, and repeat this algorithm until all the array elements are marked. And in the end, we will return the score that we will get after applying the above algorithm. Then in example 1, for the given nums array, this is how the algorithm will work. We will pick up the smallest unmarked element in the nums array, and that is 1. So we will mark it and its two adjacent elements and add the value to the score, which will be 1 this time. So our score now becomes 1. Then the next smallest unmarked element is 2. So we will mark it and its two adjacent elements. So here there is no element on the right, but there is one on the left. So we will mark it and add the value to the score. So now our score becomes 3. And after that, there is only one unmarked element, which is 4. So we will again mark it and add the value to the score. So now our score becomes 7. And now we have marked all the elements in the array. So our total score is equal to 7, which will be our answer. Now in terms of solution, one of the naive approach can be that we find the minimum element in the array by iterating through it, add its value to the score if it is not already visited, and mark it and its adjacent elements visited as well. We can use Boolean array of same size as nums to mark the elements visited by setting the visited elements position to true. But the time complexity of this approach will be O of n square, as finding the minimum elements takes O of n time, and this operation is performed for each element in the array, resulting in total time complexity of O of n square, which is super inefficient. And the bottleneck here is finding the minimum element again and again. And which data structures excels here? It is Minheap, because finding the minimum element in the Minheap takes O of 1 time. However, once we identify the minimum element, we need to mark it as visited, which means we have to also pull this element out, and this operation takes O of log n time, where n is number of elements in the min heap, which is way better than O of n when we were iterating through the array. Also, we can't just store the elements values in the heap, we also need to store their indices, because we need to mark not only the chosen element but also its adjacent elements visited, for which again we can use the Boolean array. By storing both the elements and its index in the min heap, we can efficiently manage the marking process for the adjacent elements. So our approach can be that we insert all the elements along with their indices in the min heap, and we have to write the comparator in such a way that in case of a tie, we want to get the element with the smallest index first. And first we add 2 with index 0, then we add 1 with index 1, then we add 3 at index 2, 4 with index 3, 5 at index 4, and 2 again with index 5. Also note there is a tie between the value 2 at 0th index and 5th index, and when pulling out the minimum element from the heap, we will prefer 2 at 0th index over 2 at 5th index. So this is how the min heap is created. Now we can start the simulation. Let's also create Boolean array visited to mark the elements visited. Initially all the values are false, denoting none of the elements are visited or marked. Also initial score is equal to 0. Now we will pop out the smallest element from the min heap, which is 1 with corresponding index 1. And we can see that 1 is not yet marked because visited flag at index 1 is not yet set. So we will add the value to the score and mark this element as visited by setting the flag at first index in the visited or marked array, and the adjacent elements as visited as well. So 0th index will also be visited now, and second index will also be visited. And we will continue with this algorithm until we have marked all the elements. So we pull out the minimum element from the heap again. This time it is 2 with index 0. Because in case of a tie, we want the element with the smallest index. So we pull it out and we can see that 0th index is already marked as visited. So we ignore it. Then we pick up the next smallest element from the heap, and that will be 2 again at the 5th index. So we pull it out and add its value to the score and mark it as visited along with its adjacent elements. And the adjacent elements will be at indices 4 and 6, but 6 is out of bounds. So we will set the value at 4th index as true. And then the next element that we will pull out from the heap will be 3, but the index of 3, that is 2, is already marked as visited, so we will ignore it. Then the next element we pull out from the heap will be 4, and we can see that the index 3 is not yet visited, so we will add its value to the score and mark this element as visited as well. And the adjacent indices 2 and 4 are already marked as visited, so we will continue. And then the last element we pull out from the heap is 5, and we can see that index for 5, that is 4, is already visited, so we will ignore it. And now our heap is empty, so that means we have gone through all the elements in the nums array, and our total score will be equal to 7, which we will return as our answer. Now let's jump into the code part. First, let's create Minheap, and in Java we can use priority queue implementation for that. We will be storing an array of 2 integers, which is the number in the nums array along with its index. And in the comparator, we will check if the numbers are different, then we will prioritize smaller number over larger number. But if they are same, then the number should be ordered by their indices. Now we will go through all the elements in the array and add the number along with its index to the heap. Let's also create a boolean array of size n to track visited indices. Initially all the values are false, indicating none of the elements are marked. Let's also initialize our score answer equal to 0. Now, while the priority queue is not empty, we will extract the smallest number index pair from the min heap, and if the index of this element is already marked, then we will skip this number. Otherwise, we will add current number to the score and also mark current index as visited. We have to also mark its adjacent elements as visited. So for that, we check if index on the right is within bounds, that is it is less than n, then we will mark it as visited. Similarly, if the index on the left of the current index is within bounds, that is it is more than equal to 0, then we will mark it as visited as well. And after processing all the elements in the heap, we will return the final score answer. Now let's submit this code. Cool. In terms of time complexity, it will be O of n log n, where n is number of elements in the array. Because adding an element or removing the minimum element from min heap takes log n time. And first we are inserting all the elements into the min heap one by one. So that takes O of n log n time. And then we are polling or extracting all the elements in the min heap. That again takes O of n log n time. So because of this, the overall time complexity is O of n log n. And in terms of space complexity, it will be O of n for storing all the elements from the nums array in the min heap. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.